All right, welcome to Chapter 4, Section 8. Use the quadratic formula and the discriminant. All right, so quadratic formula. It's going to be a similar definition to completing the square, but a quadratic formula is a process to find the zeros of a quadratic. Zeros of a quadratic. The discriminant is part of the QF, quadratic formula, that tells you the number and type of solutions. All right, because just to let you know, a quadratic equation looks something, of course much nicer than this, something like this. And you know this is an x squared type equation, and there are two zeros. Now it just so happens that the zeros are located on the x-intercept, where y is equal to 0. So what happens now is as this blue line moves up, let's make this now a green line, this is still an x squared. There are still two zeros. The only difference is that these two zeros, one happens twice. And we'll talk about this in a future chapter. It's called multiplicity. It actually comes here and it happens 2 times. But if you have a graph that looks like this, right, this is still an x squared. X squared still has 2 zeros, but they're special. These zeros are imaginary. Okay, so that's what the discriminant will tell us, whether it's two zeros, 2 real ones, whether it's one that happens twice, or it's imaginary. All right, so let's get started. Here's the formula. You're going to put something in standard form. So why don't you add this in here? In standard form, that's going to be ax squared plus bx plus c equals 0. You use this formula. X equals negative b plus or minus b squared minus 4 times a times c all over 2a. So you're going to use a, b, and c in this equation. Now, there is a way that I remember it, and sometimes if I forget it, I'll actually hum it to myself so I remember how to remember the quadratic formula. It goes to the an old nursery rhyme tune. It's like Pop Goes the Weasel or something like that, and you're going to get to hear me sing it. And this will be on video for everyone all over the world to hear if they want. But you read the formula as if it's a song. So it goes, let me get ready. And here we go. So it's x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So as you sing it, you would actually be writing out this formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. And that's it. If you can remember that tune, if you can remember this formula, you know a way to find the zeros for something in quadratic formula. So, solve the equation. First thing we need to do is write it in standard form by subtracting 6 from both sides. It will be beneficial to you if you actually label A, B, and C as 1, 7, and -6 before you plug it in there. Because x equals opposite B, so that's -7, plus or minus square root B squared, so 7 squared, minus 4 times A times C, all over 2 times A. And now you're going to have to do some substituting. You're going to have to make, oh, we already substituted. But now you should do some simplifying. So this is -7. Inside here, 7 squared is 49. Minus 4 times 1 times -6. Well, let's actually go ahead and work that out. It's -4 times 1 times -6. Well, that changes this to a positive 24. 6 times 4 is 24. All over 2 times 1 is just 2. So now as we're working through this, 49 plus 24, it's 25. So now you've got -7 plus or minus the square root of 25 all over 2. And we need to do some simplifying. You do simplifying by saying this right here is equal to 5. And that -7 plus 5, -7 plus 5 is -2. So -2 over 2, which is approximately -1. Or you could have -7 minus 5, which is -12 over 2, which ends up being -6. So these are your two possible solutions. And of course, the process is right? And I'd probably be yelling at you right now if you let me get this far without stopping me. But all of you should have looked right here and said 49 plus 24 definitely is not 25. Okay? So we need to do some fixing up here. Okay, it's definitely not 25, which definitely then changes this stuff right here. So if you're working with pencil, you're going to do some erasing. If you're working with pen, you should probably do some crossing out at this moment. Because 49 plus 24 is 73. Which means my answer is -7 plus the square root of 73 over 2. Oh, I'm sorry. -7 plus the square root of 73, or -7 minus the square root of 73 over 2. These are the exact answers. If you typed them into the calculator, you're going to want to type it as -7 plus square root 73. Put that in parentheses and divide by 2. That will give you your approximated decimal answers. And there you go. There's your estimated answers. All right, let's check this one out. Hopefully I won't make any mistakes this time. This had 2 real solutions. You came up with 2 real solutions. Here, you'll end up with 1 real solution. This will be where the graph barely touches the x-axis. So A is 2, B is -8, and C is 8. So x equals opposite B. So instead of -8, it's +8 this time. Plus or minus square root B squared minus 4AC all over 2A. So I'm going to have to do a little bit of work on the side here. You've got 8 plus or minus the square root of 64 minus 4 times 2 times 8. Well, 4 times 2 is 8 times 8 is also 64 all over 4. So 64 minus 64, 8 plus or minus the square root of 0. And what you're eventually going to see is that you end up with 8 over 4, which is 2. So the solution is 2. That means whatever the graph looks like, it's going to be a graph that comes and touches 2 and then comes back up. All right, an equation with imaginary solutions. Well, this time A is -1, B is 2, and C, well, let's put it in standard form, is -5. So as we plug things in there, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. I plugged the information into the song, into the equation, and now let's do some simplifying. -2 plus or minus the square root of 4 minus a minus is positive, so that's minus 20 all over -2. And from here, you see that you've got a negative in the radical. And so when you have a negative in the radical, that negative comes out. As an imaginary unit. And the square root of 16 is something we know. We know the square root of 16 is 4. So -2 plus or minus 4i all over -2. And now we simplify. You have to be very careful how you simplify, because this -2 is dividing both of those numbers. So -2 over -2 becomes 1. Plus or minus 4 over -2 just stays plus or minus 2i. So my answers are 1 plus 2i and 1 minus 2i. There is no decimal approximation that you can come up with for these. All right, look at guided practice number 2. Make sure you try 1 and 3 on your own. 4x squared minus 10x, 2x minus 9. All right, is this in standard form? You should be saying no, it needs to equal 0. So I'm going to subtract 2x and add 9 to both sides. So again, subtracting 2x makes that a 12. Equals 0. Now I know my A, B, and my C. A is 4, B is -12, C is 9. So I sing the song. X equals opposite B plus or minus square root B squared minus 4AC. Sometimes it's hard to sing the song. All over 2A. All right, simplify it. Or do some reducing or simplifying, or however you want to call it. -12 squared is 144. 4 times 9 is 36 times 4. 144 all over 8. So 144 minus 144 becomes a big fat 0. Oops. big fat 0, so it's 12 over 8, which reduces to 3 halves. That's it. 3 halves is our only solution. Your graph would be a parabola that comes down, barely touches at 1/2 or 3, I'm sorry, 3 halves or 1.5, and goes from there. All right. I'm going to go ahead and do number 2. You do number 1. So put it in standard form. Subtract 7x, add 25 to both sides. You get 4x squared minus 20x plus 25 equals 0. Now, you do not, when you are asked this on a test or something like that, unless it specifically says use the quadratic formula, you could factor it. You could complete the square, or now you can quadratic formula. A is 4, B is -20, C is 25. So, oops. So x equals the opposite b. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So 20 squared is 400. 4 times 25 is 100, so that's 400. All over 2 times 4, all over 8. So my answer here is 20 over 8, or 5 halves. Again, a single solution. So that shows you a solution of 1 that happens twice. If you did do the number 1, the answer to number 1 should give you -4, -2 as your 2 possible zeros. I would pause the video and try to do number 3 as well. 3 is an imaginary solution. It deals with the answer after all the reductions is 1 plus or minus I. That's the simplest form you can come up with. I'm going to go ahead and do number 4 for you. If you look at this, A is 1, B is -3, C is 3, and we use the quadratic formula to solve. So x is equal to the opposite of b. So if b is -3, the opposite's +3, plus or minus the square root of -3 squared times -4 times a times c all over 2a. So let's simplify that. Let's do some of the math operations. This is 9 minus 12. So you end up with 3 plus or minus the square root of -3 over 2. All right. We're pretty much simplified except for the fact that this negative needs to go on the outside as an imaginary number. 3 plus or minus I square root 3 over 2. Those are your 2 solutions, the positive and the negative. All right. Let's talk about the discriminant now. The discriminant is the inside part. So when you're looking at the formula, opposite b plus or minus the square root b squared minus 4ac all over 2a, the inside part is the part that is the discriminant and tells you the type of solution. If the discriminant is greater than 0. If it's positive, it has 2 real solutions. And the graph has 2 x-intercepts. If it's equal to 0, the equation has 1 real solution. But I'm going to add a note here, and I'm going to say that it happens twice. And when there's 1 real solution, it has 1 x-intercept. And now when the discriminant is less than 0, it has 2 imaginary solutions in which the graph has no x-intercepts. So if we take a look at the graphs, when the discriminant is equal to a positive number, the graph will cross the x-axis twice. It'll look like this. If the discriminant is equal to a negative number, then it'll end up, oh, I'm sorry. Negative number, it means it never crosses the x-axis at all. There are no x-intercepts. Then for b squared minus 4ac equals 0, you're going to have a graph, a parabola, that comes down and barely touches the x-axis somewhere. That's that one little place. These places are the solution, the real solutions. This is imaginary. So let's take a look at this example here. All these different possibilities here. The discriminant. So for the first one, A is 1, B is 6, and C is 5. So we would have 6 squared minus 4 times 1 times 5. That's 36 minus 20, which ends up equaling 14. Oh, no, 16. Which means that there are 2 real. Now when A is equal to 1, B is equal to 6, and C is equal to 9, we set it up 6 squared minus 4 times 1 times 9, which is equivalent to 36 minus 36, which equals 0 and tells us there is 1 real solution. The last choice, you can probably guess what it is. A equals 1, B equals 6, and C equals 13. Nope, we've got 6 squared minus 4 times 1 times 13, which is 36 minus 52, which when you do that subtraction is negative 16, which means 2 imaginary solutions. All right, let's take a look at the guided practice, 5 to 6, or 5 and 6, or 5 and 8. Let's find the discriminant of the quadratic and the number and type of solutions. So number 5 is 3x squared plus 12x plus 12 equals 0. Let's find the discriminant first. A equals 3, B equals 12, C equals 12. So x, we're not finding the zeros, we're looking for the determinant. So we're only doing b squared minus 4ac. Well, that's 12 squared minus 4 times 3 times 12. That's 144 minus 144, which gives us 0. Therefore, if the discriminant is 0, then this has one real solution. Let's look at number 8. Follow the same steps. 4x squared plus 3x plus 12 equals 3 minus 3x. All right, so before we can find the discriminant, this thing has to be in standard form. So we need to move the 3 and the 3x to the other side to give us 4x squared plus 6x minus 9 equals 0. Now we know A is 4, we know B is 6, and we know C is negative 9. So the discriminant is B squared minus 4AC. We know B is 6 squared minus 4 times A times C. Well, that's 36 minus, let's see, what is that? 4 times 4 is 16. 16 times 9 is 144. And then when you subtract 36 minus 144, you end up with negative 108. So I'm not asking you what is the solution. You're looking at the discriminant and you're saying two imaginary solutions. That's what you're doing here. So you can see we're pretty close. I'm going to do 6, find the discriminant. A is 1, B is 4, C is 3. So B squared minus 4 times A times C. That's 16 minus 12 is 4. Tells us right away it's two real solutions because it's positive. You go ahead and pause the video and you try number 5 on your own. Okay, number 5 should have been negative 4, which means it's two imaginary solutions. So, number 8, I'll do number 8. You're looking at the A equals 1, B equals 6, C equals 4. You have to plug it into the B squared minus 4AC, the discriminant, as 6 squared minus 4 times 1 times 4. That's 36 minus 16, and that's 20. So I'm not asking you to actually find the solutions. Just say that for number 8, there are two real solutions. Pause the video, try number 7 on your own. And when you're done, unpause it, and the answer should be there. So after you do all the discriminant here, you should end up that the discriminant is 0, which means there is one real solution. All right, let's do guided practice number 10. You're going to use the formula h equals negative 16 t squared plus the initial velocity times time plus the initial height. And this is talking about solving vertical things in vertical motion. So for number 10, it's saying suppose the ball leaves the juggler hands with an initial velocity is 50. All right, so like I said, the initial velocity was 50 feet per second up. How long is the ball in the air? So you have to go back to example 5 in a book, which says that the juggler's hand is 4 feet. So the initial, that sub-0 represents initial. So the initial height was 4, and when it falls back, so what is the time, h, it takes for it to get back to 3? So the ball is going to start here, it's going to go up, and it's going to come back down, and we want to know when it hits 3 feet. So we plug that information in. 3 equals negative 16t squared plus 50t plus 4. Let's subtract 3 from both sides. So my standard form equation is negative 16t squared plus 50t plus 4. So plugging it into b squared minus, oh, I'm sorry, we need to find when does this actually equal. We're not just doing discriminant now, we're doing the whole formula. So now we're doing x equals opposite b plus or minus square root b squared minus 4ac all over 2a. All right. So you're taking this and you're going to simplify it now. So negative 50 still, plus or minus the square root of, well, 50 squared is 2500. And then you've got a negative 4 times a negative 16 times a 4, which is 256. Let's go plus 256 divided by negative 32. And so you're going to run that through both ways into your calculator because we're not going to deal with a time that is negative. We're not going to go back in time to see. So you're going to type this in there. Type it into your calculator, each piece the right way. Put parentheses around this. Divide it by negative 32. And let's see what our solutions are. So your two choices should have been negative 0.078 or 3.203. And again, which one makes sense? The positive time makes sense. So it took about 3 seconds for that ball to come back down. All right, so that's it for this section. Good luck. Make sure you do the rest of the guided practices. There's only a few more that you need to do. And you're going to work on these in class. So good luck.